Alright, it's time for the math. Easy solution to discuss. Something I found a while ago. It's pretty ridiculous. You could graph a heart with the Google search calculator. I'll show you an explanation of this. Basically, you look at this equation, and then you could just this square root of cos x times whatnot. So you could plug this in actually into Google searches, copy and paste. You could also copy and paste from I put this in the info below. So you put this in the Google calculator, Google search, and then you get a heart. This is pretty sweet. So when you zoom in, you can see that it's a trigonomic function. You can see it goes up and down. You can play around with it. Let's just go put it at 100. And you can see, it goes up and down like that. If you put it even, let's say, at 10, then it doesn't look like a heart anymore, but you kind of get the idea. Let's put it back to 400. And now you could also stretch it with this one. Let's say 9. So it's kind of stretched outwards and whatnot. Let's just put it back to 4. You can also play around with this and see what this happens to 4. Yeah, see, it's kind of messes it up some weird way. So I'll go through a brief explanation of some of the like terms in this equation. So basically, let's write it down in a bit neater way instead of just written out like this. So basically, this one it's just going to be as well square root cos x, and then times it by cos 400 times x, and then in this one, then we plus square root absolute value of x, and then minus 0.4, and then all times it by 4 minus x squared power 0.1. Okay, so when we look at this equation, let's look at the leftmost first. Let's look at this one right here. Well, we know that cos x is just it's a trigonomic function that it kind of goes like this. This one's cos x, but then with the square root in here, we know that square root cos x has to be the inside has to be greater than 0. So cos x greater than equal to 0. So then we only look at the top part here. We could also graph it out. Let's graph it out. Square root cos x. Yeah, this one is, as you can see, it goes to, well, this one is pi over 2 because that's where it's 0, and then it ignores all of the negative values. So this is pretty sweet. Okay, now let's if we look at this one right here, the cos 400x. As you can see that, like with a regular cosine curve, this is cos x. We know that the period, or at the point where it starts repeating itself, is just going to be 2 pi, just like a circle. But then, so then at 2 pi, this one starts repeating itself. But then for this case, this one's actually going to be much smaller. So because if you have 400x equals to 2 pi, if you want to just solve when, as we know that this is at x equals 2 pi, in this case, is when it starts repeating itself, so at x equals 2 pi, but in this case 400x equals 2 pi, so then x is equal to, well, or the period is just going to be equal to pi over 200. So this one is really, really small, so when we graph it, let's just graph it separately. So when we graph, let's say cos 400x, yeah, as you can see, this is very, very small. I mean, it keeps going up and down really, really fast. So if you were to graph side by side by the cos, as you can see, yeah, it's way out of, it's completely away from. So as you can see the red, it's kind of going there. So then this one the period is much smaller. Okay. So now let's look at this one right here. This one, if we look at this one alone, because we know that the absolute value is just going to be like this. This is just the absolute value of x. But then, and then we know that square root of this is just going to be, it's going to be like this. This is just square root x. But then it's absolute value of square root x, so we're going to have it on both sides. And you could also just graph this one separately. Square root, let's say abs x. As you can see, yeah, it's just a square root x, but on both sides, it's a mirror image. Okay, so now let's look at this one. Yeah, the minus 0.4. This kind of, what is it? It kind of stretches it, I'm not too sure. But let's look at this one right here, and then I'll put them together one by one, see what happens. So 4 minus x squared. If you were to, let's go right here, 4 minus, well, we have it right there. So this one, as you can see, that the inside can't be less than 0, because this is the square root 0.1, or power of 0.1. It's like a power of square root, so it has to be positive inside. And so then from here to the largest x value is 2, and the smallest negative 2. So you can see right here, yeah, that's 2, negative 2. So from this one we know that x is less than equal to 2 and greater than equal to 2. But then when we look at this one right here, we know that cos pi, like this one right here, negative 2 is somewhere over here. Where's negative 2? So negative 2 is over here, so we can only look at the only place that will have values is where this is at, where this is 0. So this is a cos x, square root cos x. So this is when it's 0 initially, so this one is, because we know that cos x at equals pi over 2, we know that cos pi over 2 is 0. So then, in this case, because this one is between 2 and negative 2, and then this one we only have to consider this curve here and ignore all the others. So we're going to be left with, from this one, we're going to be left with, for the final equation, x is less than pi over 2 and greater than pi over 2. And pi over 2, if you just type it in, let's just write pi over 2. This one's 1.57. I'll just write that down here. I'll just write it a bit neater over here. So we know that x is less than pi over 2, greater than pi over 2, or negative pi over 2. Let's put a negative here. Or this one is just, let's just 1.57 onwards, and greater than negative 1.57. And it keeps going on. And you can see that from this curve here. If you look at the leftmost here, as you can see, if you look at this x coordinate here, as you can see, it's reaching 1.57 around there. It's only one where, yeah, if you go beyond it, y is undefined. So it's 1.57 is the outmost. Okay, so now we understand these two curves. All these curves. Let's put them together. So we go from here. Let's just write square root, yeah, cos x. So if this one, let's just multiply this one out now by cos 400. Let's see what happens. So if you multiply it out by this, you get this one. And this does make sense because we know that it's all we're going to be looking at is the initial one here. We're going to be having all the values in the cos one like this, multiplying by every single thing like this. This is the cos 4x, and as you can see, this one, it just looks something like this. So you just put that through your head. So basically, we got this one right here. And now, let's add, now we're going to add square root abs x. Let's see what happens here. So as you see, yeah, this one we actually have a heart in the center, because at the beginning it's going to be something like this. So we're adding every single value of this to that circle we got, or that oval. And initially here we don't add much, so that it's smaller out like this, and then for these ones are more round because it's more uniform. The square roots are more uniform, where this one is big change, and that's why it looks kind of like a heart. Okay, now let's see what happens here. We'll just ignore the minus 0.4 and see how it comes in handy. Put the brackets on both sides, times by 4 minus is x squared. Power of, let's just write, yeah, this is 0.1. Yeah, so right now we get a awkward looking heart. And then since we added this one, we don't have those extra these extra circles, because we have now it's less than 2 and greater than 2. I'm less than 2 and greater than -2. So now we just play around with this. Add, let's say, -0.4 to make it more evenly spaced out like that. So yeah, that's all. That's all for today. Hopefully you'll learn, and you could just play around with this one. You could zoom in, see how tiny it is. Look at this, is pretty ridiculous. But yeah, if you ever wanted to show someone something cool in Google, just graph this out and send it to them. You could also find it in the in the info below, and you can see this equation. You could try it yourself. Well, that's all for today. Hopefully you learned, and stay tuned for another math easy solution.